Hello, everyone. Fantastic to be here, and even better to see such an awesome crowd. My name is Patrycja, and today we are going to explore live Kubernetes hacking together. So, get ready for a ride. First, a brief introduction. I've been doing professional software development for over 20 years. Yep, sometimes I do feel like a vintage dinosaur. But hey, who doesn't love a classic? I've always been close to code, and that bond still thrives today. However, almost 2 years ago, I joined the dark side of platform engineering at Forum 3. And guess what? I absolutely loved it. Today, I'm a lead SRE engineer there. So what do we do at Forum 3? In short, Forum 3 is financial cloud. We provide a payment as a platform model for easy and quick integration with various payment schemes via REST API. We are technology-oriented, fully remote, cloud-based with microservices architecture. We treat our infrastructure as code almost religiously, terraforming everything possible. Lately, we are building a new multi-cloud payment platform based on Kubernetes and 3 clouds. So obviously, Kubernetes security is super important to us. What am I going to talk today? Just a splash of theory in the ocean of practice, hopefully. The key part of today's talk features 2 demos to hijack your accounts, exploiting various security issues in a Kubernetes application as well as a cluster. But before the fun begins, let's do a quick review of the Kubernetes architecture. There is 2 main concepts in Kubernetes: the control plane and worker nodes. The control plane basically manages the entire cluster. The heart here is an API server. When we want to create or update any Kubernetes resource, we need to communicate with that server. It exposes a Kubernetes HTTP API. That way, we can interact with the cluster using tools like kubectl. And who doesn't know kubectl? Worker nodes, on the other hand, are the place where the real work happens. The actual pods run over there. So the main component here is kubelet. Kubelet runs on every node and is responsible for instantiation and execution of pods on a given node. Like the API server, kubelet also exposes a REST API, but it's only like internal API for communication between the control plane and worker nodes. However, sneak peek, we'll exploit an unsecured kubelet API to gain unauthorized access to the cluster. What other kind of security issues can we see in our K8s clusters? Now it's time to dive into the OWASP top 10 security risks. Who knows OWASP? I think everyone. OWASP is a non-for-profit organization aiming at increasing security awareness among developers. They publish top 10 lists of security risks for various technologies. And only last year, for the very first time, they published such a list for Kubernetes. This list is like a hit parade, so let's check out our chart toppers. Number 1, insecure workload configuration. Basically, watch out for root users, writable file systems, or privileged mode. Number 2, supply chain vulnerabilities. Keep an eye on how you build, package, and distribute your applications. Number 3, basically don't be too generous with RBAC permissions, or it's like you are throwing a party that anyone can crash. Number 4, a good piece of advice here is to centralize your policies, basically to reject any misconfigured Kubernetes resources. Number 5, if you don't watch your logs, you are like a security guard who fell asleep on the job. Number 6, make sure your authentication isn't like a weak bouncer who just lets anyone in. Number 7, important note here is to remind you that Kubernetes has this flat network security model. What does it mean? It means that any pod can communicate with any other pod without any restrictions. And in terms of security, it means like having all the doors in your house wide open. What do we need to do? Basically, we need to lock them up. Number 8, protect your secrets. As simple as that. However, in practice, it depends. By the way, I had this talk at GeeCON only on Wednesday, and also a colleague of mine was having a talk on external secrets operator. So some external tools might be needed in this case to protect your secrets properly. And number 9, misconfigured cluster components. As easy as it sounds, and it's not in practice, secure your cluster components, because otherwise you'll end up like a messy Kubernetes jumble. And last but not least, keep your Kubernetes components as well as your application workloads up to date, or you might end up with a bunch of uninvited guests in your cluster. So that's it when it comes to theory. Let's see those issues in practice. This will be like a 101 course in Kubernetes hacking, but hopefully you will get a sense of danger here, and you will see how a series of simple misconfigurations can lead to the compromise of the entire system. And now I will need your help. I have this vulnerable application prepared. The links available in the slide, as well as in my Twitter account. My Twitter account is just Yon Labs. So my kind question to you, please register a new account, log in, and wait to be hacked. My objective here is to hijack your accounts and learn your secrets. So let the fun begin. Now I will show you the application that's available under geecon.yonlabs.com domain name. You can also see the link on my Twitter account. My Twitter account is Yon Labs. If you go over there, there is the tweet, and we have a link here. So please register new accounts. Obviously, use some sort of a nickname. Don't use your real data. Don't reuse your real passwords. That's a big no. And let me see who is in. Oh my God, we already have some new accounts registered. So after you log in, you just see your profile with some secret data. You can update it, and we can see the list of active users. So we see that there is a couple of new users registered. So once we know that we have some accounts to be hacked, so let's move to my terminal. I will log in to my evil server. Evil server is a place from which I will do all the hacking today. And usually when a hacker is in or is trying to find some issues, it performs some sort of reconnaissance. So usually it's like port scanning with tools like Nmap or Netcat. Here we are targeting Kubernetes cluster. So I will use a tool dedicated for this one, and that's kubectl. So let me see what kubectl can do for me. What I'm interested in is the scan command. Basically, maybe a brief intro to kubectl. As you can imagine, kubectl is a similar tool to kubectl. It's kind of a wrapper around this kubelet REST API. That's a tool implemented by CyberArk. That's a cybersecurity company, and just a simple helper to help with reconnaissance around Kubernetes API, specifically kubelet API. So here we have the scan command. This scan command can scan for open kubelet API. So let me scan for this in this small subnet. Basically, what's the architecture here? I have a Kubernetes cluster, my victim cluster, in some sort of a subnet in AWS, and in the same cluster, in the same subnet, I have this evil server. So that's a private subnet. I haven't opened my Kubernetes cluster to public because I would end up pretty quickly with some exploits on my server, because obviously, yes, I have an open kubelet API. What a surprise, right? So kubectl found an open kubelet API. What can I do here? I could curl this. That's easy. We are getting 404. Why? Because there is no endpoint listening on this path. So let's query pods path. And we have something here, but let's make it more readable. We have the list of pods here, but maybe it's gonna be better just to show the names of our pods. Okay, we have some pods available. So that's the first thing. We know that we have access to a Kubernetes worker node. We can query for pods, and once we have access to this open kubelet API, we can for example, schedule a new pod. We can execute commands inside a pod. However, it's going to take some time to explore all those issues and find which pod we should target. Again, kubectl can help in this case with scan command and a couple of subcommands, because we have two subcommands available for our scan command in kubectl. That's RCE, remote code execution. Basically, it looks for pods with exec permissions, whether or not we can execute any command inside a pod. And also very useful subcommand, it's token command. Basically, it searches for all the tokens in a given node. Again, once we find some token, we could escalate further, for example, take over and the entire node. But here, I would like to take a look at this RCE subcommand. So let's see what kubectl says here. And it says that, yes, we have remote code execution available in a couple of our pods. If you take a look, that's, for example, Calico. Calico is a Kubernetes CNI plugin, and that's a default installation of Calico. And it allows for command execution inside a pod. But here, we have this demo server and demo web, so most likely that's our application. Am I right? Perhaps yes, because I've prepared those demos, right? Okay, so let's give it a try and do execute some command over there. So in this, oops, sorry, that's not the correct one. In this pod, in this namespace backend and container demo and our server, we are going, let's execute whoami command. And whoami says, I'm root. That's another nice coincidence. As a root, we can obviously perform much more harm than as a regular user. So never run your pods and your deployments as a root user. Anyway, now we know that we can access and execute commands inside a pod. So what can we do here? A typical scenario in such a case is to establish a reverse shell. What is a reverse shell? When you think about a regular scenario for a regular user, when you want to connect to a remote server, from a client machine, you do like SSH command to a remote server, you provide your login credentials, and then you are given a shell. The reverse shell is like the other way around. Instead of a client machine connecting to a remote cluster, a remote server connects to a client machine, this way bypassing credential and authentication step. So to establish a reverse shell, usually we use such tool as NC netcat. For this one, I will need another terminal window. So I will log into my evil server once again, and I will start listening. Because in order to establish this reverse shell, a client machine must have some sort of a listener. So we listen on port 4444 with our NC, and then in kubectl, we want to connect to this NC listening process. So it's listening on my evil server. That's a variable with the IP of this server. We are listening on port 443, and we want to expose a shell. Let me see, and you see that connection has been received, so it seems like we are in. Let's see. Okay, you can see what's here. And usually as a hacker, we just sniff around. We sniff around and see what can we do. Usually sniffing is like checking who we are. Yeah, we know that we are root here. Let's check out mounts because, for example, when a pod is runs in a privileged mode, we could, together with root, we could just take over the entire host. Unfortunately, here we see that this pod doesn't run in a privileged mode, so let's sniff around and see what listens on the spot. Okay, we have this process listening on 1990 port. So perhaps it would be good to just sniff traffic here. Do we have TCP dump for this one? Unfortunately, we don't have. I'm using redirect here. Why? Because usually with a reverse shell, you don't have like fully interactive shell. So it doesn't show like standard errors. You can't use like your history. So there is some limitations. And also there is some ways to pimp your shell up. However, it's like a more time consuming process. So here I'm staying with this simple reverse shell instead of upgrading it to a fully interactive shell. But let's do one more thing. Let's see if we have a writable file system. Do we have writable file system? Yes, we have. So when we have a writable file system and we have open egress to the internet, basically we can install whatever we want as a hackers. Let's try to install TCP dump with APK. Usually APK is available, and here it's available as well. Okay, so we have TCP dump. So now let's listen and sniff traffic on port 99 for our pod. I have one request to you. Could you please refresh your pages in our vulnerable application? I would like to see some traffic. Yep, and I see something. Thank you for your cooperation. And let's take a look what we have here. Oh, what a surprise. We have a bearer token. Let's copy this one. And let's move to our application. Here. And let's try to use this token. I've just replaced my valid token with the one I've just copied. Let me refresh the page, and I'm as aether97. You've been hacked. Congratulations. Are you here? Yeah, we've got our winner. Thank you. So let's get back to our slides, and let's sum up what happened here. What problems did we see during our demo? The main problem was an open kubelet API. If we take a look at our official Kubernetes documentation, we see that those are the defaults. Pretty scary, right? The default setting for anonymous authentication is true, which basically means that any anonymous request to kubelet server is allowed. And together with this anonymous access, the another default for authorization mode is always allow. So basically, once you have access to kubelet, you have access to the entire stuff on a given node. Fortunately, we usually use like managed Kubernetes in cloud, like EKS, GKE, or AKS, or we use like a proven installation method like kubeadm, and those have sensible security defaults. So usually we are good as long as we use those managed Kubernetes clusters or we use proper installation method. However, it's always good to check out what you use and check out what's available in your case. Some more issues spotted during our demos. Another problem is writable file system. You could see that with a writable file system in a container, you can have like a lot of potential security risks. Why? Because once a hacker is in, he can install or extra tools, or they can modify existing code of your application or your workload running in a given pod. So basically ensure that your containers run with a read-only file system. Another thing is running as root. Here we actually haven't exploited this root thing apart from running APK, but that sometimes we could do that or install TCP dump just by downloading it from the internet, so that's not the main problem. However, this is another configuration we should pay more attention to, because running as root together with other issues in our cluster could lead to a total compromise of a given node. With containers, we also should limit what's possible and available inside a container. Here we had quite a few tools available, like netcat, so we could establish a reverse, as hackers, we could establish a reverse shell. Usually, it's better to use distro-less images. However, you must be aware that even distro-less images don't guarantee like 100 secure workload. And there is a very interesting blog post from a colleague of mine from Form3. He's a team lead of our offensive security team. And in this blog post, basically, he sums up the way to exploit even distro-less images. So what we are seeing here is like a basic and foundation for securing your Kubernetes workloads, and that's like the tip of the iceberg only. Another thing is networking. Even though if you take a look at our application, you see that it's HTTPS. But inside a cluster, between a load balancer and actual pod executing a command, we have HTTP only, without encryption. So that's a problem. And actually, I'm not able to count how many times I had this discussion with less experienced DevOps developers that, oh, come on, when it comes to internal networks, you don't need to encrypt your traffic. That's only like private network. Nobody has access to it. We are safe. And think about performance. At some point, first of all, it's not such a huge performance overhead. And on the other hand, security is gaining more and more of a momentum, and we have more and more of security problems. So the concept of defense in depth is very important. We should have those stacked layers of security controls to make sure that our clusters and our workloads are safe. And another issue, open egress to the internet. So allowing unrestricted egress to the internet, we can expose our workloads and clusters to any external threats. It's very easy to download extra tools and make more harm once a hacker is in. So by addressing these vulnerabilities and implementing proper security measures, we can significantly improve the overall security of our Kubernetes clusters. So now it's time for our second demo. This time to hijack your account, I will exploit another application deployed in the same cluster. So let me move to this rce.yonlabs.com application. That's a simple hello application. Oops, I have a problem here. Okay, it works. Oh, for a moment it was like, I was very scary what to do if it doesn't work. Anyway, so we have this, no, it doesn't work. Let me see what I can do here. Actually, I will log to my so here I will log to my actual K8s cluster and see what's going on here. So let me see K9s. Let me see my RCE workload. It looks like it's running, so most likely that's something with my load balancer. So let me see what's going on in my AWS account. That's quite a surprise because I did this demo like at GeeCON 2 days ago and everything was working. Perhaps, and actually you can see that the age is pretty long here. So let me see. I think that I know what happened here. I think that someone unfortunately hacked my server. So yeah, it happens when you leave your vulnerable workload open to the internet. So what am I gonna do here? Let me go to RCE and I will just restart it. Because we see that basically our load balancer works. So most likely, okay, yep, that was it. Someone has exploited this RCE remote command execution here because yeah, I was about to tell you about this one. So we have this simple hello world application which says hello to you. However, it has RCE bug, remote code execution vulnerability available. So you can basically do whatever you want on the server. And yeah, someone must have exploited it after my last presentation. That was a good one, and it caught me by surprise. But fortunately, we fixed the issue, and we are good here. And don't mess up with this demo for a moment, at least. So we have this RCE vulnerability available. So basically, we can execute whatever we want. Who am I? This means that we have this www data user in our pod. It usually means that we use Apache HTTPD underneath, because that's a default user for Apache server. And what can we do here? Once we have this RCE available, it's like being a one-trick pony. We can again establish a reverse shell. So let's give it a try. So now actually I need to again log into my evil server. I need to start NC in a listening mode again. So I'm listening on this 4444 port again. And let me switch to my vulnerable application, and let me try to establish a reverse shell here. I think that was this IP. And yes, we are in again. Let's see what's going on here. Oh, and we see that we have some visitors as well. That's nice. Hello, Pavel, and that's nice that you are so fast. Okay. So what can we do here? Let's do some reconnaissance as usual. And here we see that actually this one runs in a privileged mode. So, so basically, if we were root, it would be very easy to take over the entire host node. However, we are not root, so let's not bother about that one anymore. Another thing that a hacker does is like port scanning. So let's do some port scanning. However, port scanning usually is quite time consuming here. So I'm targeting my only one IP and only one pretty small IP range, just to make it quicker. I know that we'll find something here. Let's do it. Okay, and that was very quick. We have this 6379 port open. 6379 is a default port for Redis, so most likely we have, basically we have, because that's also we see a domain name inside this cluster assigned to this IP. So we have a Redis server available. Let's go to my cheat sheet and see what we can do further. Basically, Redis doesn't expose a simple REST API. That would be easy to exploit with curl. Instead, Redis supports this RESP protocol, Redis serialization protocol. Usually that's quite common and popular for any data store systems like Redis, NATS, or databases to have custom tailored protocol. Why? Because of performance issues, usually. So instead of using quite verbose JSON, they use like more concise protocol, better suited to pass over and transfer a higher volume of data. So let's try it out, and let's try to send ping command to our Redis server. Okay, it responds with Pong, so we are in. So let's see what's available in our Redis key store. Oh my God, I'm so surprised. We have JWT tokens here. Who would imagine, right? What happens here? Basically, I'm not sure if you are familiar with the details of JSON Web Tokens. JSON Web Tokens are very popular authentication mechanism in modern web applications. However, and they are like stateless. They are like stateless session mechanism. So we don't store anything on the server side. Everything is encoded inside a JSON Web Token. But what are the drawbacks of those tokens? Basically, you have no way to invalidate them. And when it comes to security and applications, you must provide a user a way to log out. So again, how can we implement that? The state strikes back. So we need some store to keep invalidated JSON Web Tokens. And usually we use some sort of key value stores because those are easy to use and can store our tokens with some sort of expiration time. So that's most likely how it's used in this application. So I would like your help here as well. Please log out and log in again, because I would like to get some tokens in the store from you. So I will wait a couple of seconds for you to log out and log in, and then I will take some token from here. If that's a store for invalidated tokens, it means that I first need to remove one of the tokens. But first, let's see perhaps some of the tokens here. So let's copy this one and prepare a command to be executed and see what the value is stored under this key. Okay. Let's try it out. Yes, that's log out. So most likely this is like our store with invalidated tokens. Hopefully you managed to log out and log in again. So I will try and capture some new tokens here. And for this new token, I will try to remove this token and then try to replace this token with in my web application and see who this time I was able to hack. So again, replacing JSON Web Token, and this time, unfortunately, it didn't work out. So most likely it was one of my old tokens, not mine, but some old token that has expired already. So let me do it once again, and please log out and log in again in your applications. It will help me tremendously to get some new tokens to be hacked. As I said, I do kindly ask you for some cooperation, because without you, it's gonna be impossible. Okay, I think that, do we have any new? I think is it the same? I think that's the same I just used. I will do it once again. Yeah, that's the same. let me try this one. Or perhaps I have also this victim. No, that's a different one. So thank you. You've been very cooperating. That was my mistake when I said that's the same token. And let's use this one. So first, let's delete it from our Redis store. It has been deleted now. And let's copy it and use this value in our web application. So once again, replacing and refreshing. And unfortunately, that's me. So I managed to hack my account. So one last attempt. We have some more time left. Let me hack you. So again, this one. The old trick. Now you can see all the tiresome work a hacker must do to get in. And you see that it needs sometimes some sort of a coincidence, because without any traffic going, sometimes it's impossible to, for example, capture some tokens. So a hacker must wait to see some traffic. Obviously, for like popular application, it's not a problem. Everything is working, and all use most of the time we have some traffic going on. So let's copy this one and let's try to use this one again. Oh my God, that's like very unfortunate, because I'm not sure if you can see this one, but my battery is going low. Let's see how much time we have left. Okay, let's do this one. If it doesn't work, I'm giving up. Okay, it worked. Fortunately, I feel so much better. Lala1, you've been hacked. So thank you for your cooperation. You see that it's a relatively easy hacking. However, on the other hand, you need some like luck to get in. You need to align some security issues, simple security issues, in order to successfully exploit a server. So it's not a piece of cake always. So even with simple security measures, usually we can improve the overall security of our clusters. Oops, I think I have a problem here. Another one. Oh, no, I'm good. Too much bad luck today because my charger got disconnected. Okay, now I'm good. Let's get back to the summary of our second demo. And let's see what this time went wrong with our application and cluster. So we had quite a few issues in our second demo as well. First of all, remote code execution in one Kubernetes deployment could lead to a compromise of another application, only because both applications run in the same cluster. So what shall we do here? We need to segregate our workloads based on their sensitivity. It's good to consider whether we need one cluster. Maybe we should split our workloads to two clusters. And another approach, and most popular one, and something we always should do, is to implement proper network policies. So Kubernetes has some built-in Kubernetes has some built-in features for network policies, but also you can use like CNI plugins for more advanced policies. Another issue we have here is missing network segmentation. So basically with flat security, network security model in Kubernetes, any workload can communicate with any other workload without any issues. So we need to, again, properly isolate and protect sensitive workloads. Again, unnecessary tools available in our container can lead to attackers exploiting them. So that's a big no. And last but not least, anonymous access to data stores. So again, sometimes I hear arguments, oh, we don't need any authentication. We are inside our separated subnet. We are in our Kubernetes cluster, no one is allowed except, for example, administrators or developers. We should always implement those several layers of control mechanism. Otherwise, if you are unlucky, we can get with a compromised cluster. So a bit of summary what we've learned today. I can only say that today's demos just showed only the tip of the iceberg when it comes to Kubernetes security. I could go on and on about the topic, but unfortunately, or perhaps fortunately for you, we are running out of time. Unfortunately, because of my failed demos a couple of times, but we get there. Some final remarks only. It's important to remember about the Swiss cheese security model. It illustrates how important is layered security. Like stacking slices of Swiss cheese, each layer addresses different security issues, and that way we cover the holes or weaknesses in another layers. So by implementing multiple overlapping layers, we create a more resilient defense. So remember also that the goal is not to achieve like perfect security. That's impossible. We want a robust defense that makes it more challenging, more difficult for attackers to succeed, and gives us, good guys, more time to detect and respond to potential security threats. Also remember that a fool with a tool is only a fool. We DevOps cannot be fools. We need to know how to use our tools wisely. And in order to do that, there is another fundamental paradigm, continuous learning. So we must keep educating ourselves. And that's what GeeCON is all about, right? To increase our awareness and knowledge about various tools. Thank you. Thank you for your cooperation. If you have any question, just come and ask during a break.